here's another reaction, and I can tell that this reaction is a single replacement reaction because it has an ionic compound combining with an element. And so I will get, it says a reaction does occur, so I should have my element replacing something on my compound. So how I do this is I think about my element, what type of ion does it tend to form? It tends to form a -1. So that means it will replace the negative part of this compound, which would be the iodine. So I'm going to have, for my products, I'll have the sodium with the chlorine, and then my iodine will be in my elemental state, and I know that it's a halogen, so it's diatomic. So I may want to balance this as well. Okay, and then we want to say which is more active of the two elements. And so we're always comparing, you know, the element that was by itself and the one that it replaced. And so what you need to know is that the more active element ends up in the compound. And so in our case, that's going to be chlorine. Okay, again, this is a single displacement or replacement reaction. And for activity, the halogens are more active as you go up on the periodic table. That trend works for the halogens. Metals are harder to predict. So you don't need to memorize the trend for the metals, but you might want to know the trends for the halogens, that fluorine is the most active halogen. A couple other reactions that we did we need to know a little bit about. First, our decomposition reaction. You do not need to memorize the reaction, but just be familiar with what's happening and what we observed. We did have a catalyst for this one, MnO2. Okay, and this is the one where we used the glowing splint. So the potassium chlorate was a white powder. We added manganese dioxide, which is kind of a charcoal gray powder, and then we heated it. And we did this in the hood in a test tube. And then we took a glowing splint, which is basically a stick of wood, and we lit it. We blew it out so that it just had that orange ember, and then we put it up to the test tube where the oxygen was coming out, and it relit. It burned brighter. And the reason that it did that was because the flame burning is a reaction between oxygen in the air and the wood. And so when we put it up near the test tube where there's a lot of oxygen, that reaction, the combustion, could go a lot faster, and that's why it lit up. So the glowing splint was basically a way to see that oxygen was one of the products of that reaction. We also did see it bubble, so production of gas. Another reaction we did was the combination reaction. This is the one where we had copper and we heated it. And it made a copper 2 oxide. Let me balance this. Okay, remind you, this is where we used a dish, a white porcelain dish called a crucible. And we put our copper in it, and then we applied a flame, and it got really hot. And what happened is that the oxygen from the air bonded onto our copper. And so our copper, it did change colors. It kind of got gray. It gained mass, and it gained mass because the oxygen was bonding onto it. So on that one, we had two indicators of a chemical reaction. We had a color change, and we also had it gaining mass.